Record. So in our previous sessions, we have discussed about difference between a Kubernetes and Azure Kubernetes services, and what is the different types of containerization tools are there in Azure. And then we started talking about architectural components involved in a master and a worker node. I try to give majority of the differences. But this time I will try to walk through those same concepts, but from the Azure portal, and I will try to deep dive in Azure Kubernetes service. We are starting off with getting deep dive, playing with more on an AKS cluster point of view or AKS service point of view. So next couple of three sessions from now, that is third, first, next, second, and third session, we will be emphasizing on the configurations, features, all session by session. I'll try to see how much ever I could actually cover. It may be dragged, and after that, we will be working more practically on those pointers. Because more if I enhance on the configuration and then show a POC, it will be more dragged into 10 sessions like that. Instead, I will try to keep limit myself talking about in a theoretical point of view and show wherever it is a possibility to keep it and summarize it in one go. And or otherwise, I'll try to keep this 2, 3 sessions on theory and then I'll try to run things in a practical point of view, trying to show that everything in a one go. Most of the features and all that. The rest, I would recommend you to uh, understand. See, practical in terms of interview preparation only helps in terms of making you understand about the concept. Because otherwise, if you are not really being aware on the practical side, with practice చేయకపోతే, it's tough to remember the concepts. And the more you the concepts you're trying to learn and you don't understand their meaning and you're trying to just digest through the words or understanding in a not through a practice point of view, you will try to end up mugging up and you'll have a tough time remembering and recollecting or revising things. So I would go recommend side by side. At least cover some 10 concepts, and out of it, 3, 4 concepts you try to practice it. And instead of watching videos, I would recommend means on the practice videos, instead of watching on those, you try practicing 4, 5 concepts and you watch it and then try to practice it. Try to just create a machine like ATS service which we are trying to create and then just try to sample run it. Now the concepts whichever you are trying to learn in whichever there are multiple courses. If you're trying to choose Google site, you can choose it, or you can try to choose Udemy, you can try it, or you can try YouTube itself. Try to go with any Kubernetes service and understand. Okay, uh, on this. And from there, in when we are trying to talk more extensively on features, we'll end up talking some part of security of AKS cluster. Uh, See, this is just to give an idea in terms of interview point of view, how you can actually just talk about it. But we are not really trying to learn more on an AKS point of view because there are courses which you can find it, or this is not the course we are aiming for. We are aiming for majority, talking about majority concepts which we can convince in interviews that this is with what I have worked on, this is what I can do, and what market is actually looking for when they're trying to ask on Azure Kubernetes service. When you're showing that DevOps guy having so and so experience in so different platforms and DevOps platforms. Along with it, in Kubernetes, what are you aware of? So on that point of view, when we go ahead, what concepts are you should be carrying along is the emphasis on this uh, course classes or the further classes which we'll have in next 6 to 10 classes which we may have on this one. Okay. Now let me bring up. On so far, I would say for Azure Kubernetes service, uh, Microsoft documentation would be the best ones to pick it up. And these are just quick start templates on concepts. If you go, let's go for core concepts. If you see, the core concepts have been started out with saying that the cluster components, what is Kubernetes and what is AKS is there what I have tried to explain. And then we also spoke the cluster components. And if we look at it, uh, cluster components point of view, this is the API server. When you are trying to enter commands like kubectl and all that, you are trying to enter the command as an user, and that is being connected to API server. API server is the one who is listening. So this is playing, API server is playing the role of uh, for any API, the Kubernetes APIs to be interacting with the cluster. It's the first components which will be coming up. And once that is going on, now what is the command which you wanted to enter? Kubectl get nodes. Then how many nodes are there in the cluster? It's going to give the report. Get pods. How many pods are running in the cluster? Okay. What services are there? What namespaces are there? What deployments have been done? What is the exposed service? Anything on the cluster point of view, you will be entering, and that will be listening from API server, and it will do the necessary actions. Now, if you see, HCD is an entirely a different component. What is it? The key value pair, which I mentioned. Okay, and it's called highly available one. So majority of the resources will be improvised, providing to HCD for high availability, and it stores the entire configuration of the cluster. What nodes, how do you communicate with what level, and how what pods are running in what nodes, which are available, which are uh, anything down, anything cluster configuration, entire data, how many replica sets should be there, what pods have to be, how the pods have to be created. So when we are trying to do a deployment of the previously in the previous session, we tried to deploy an application. Okay, application deployers. Now we mentioned the config YAML, what should be there and everything, right? So the entire thing, what is happening? It's getting stored properly in the HCD in a way, and so communication to happen for all the components. So everything happens from HCD. So API server going to interact with HCD and going to get it. And now if you see controller manager is having the control plane components. There are different types of controllers. Pod controller, okay, node controller, okay, replica set controller, whatever it is. So all this communication happens and it will directly again interact with API server, and the scheduler is the one which is going ahead and scheduling things. If you want to create, add some node or add some replica set, add some pod or anything, whatever it is that's happening from scheduler. Now, if you go with a worker components, so in Azure, what here if you see what is happening, uh, if you see they mentioned this is Azure managed, right? Okay. And they mentioned this is customer managed. Why did they mention? So as I mentioned, control plane entirely is being managed by Ashok. You are not going to play any responsibility towards it of maintaining that and all that. So obviously, you can go ahead and talk a lot of things how your cluster have to be configured and everything from the Azure portal point of view. But your entire workloads, whatever machine applications have to will be running in this. So it's a customer managed platform is what they're trying to say. So they demand they manage this, or what do you say? They differentiated this one, and the nodes are the ones which have kubelet, kube proxy, and container runtime, which will create containers. And if you see, They are the ones which are containers are getting created and they have been turned into pods and all that. Now, kubelet is the one which will help in interacting with the control plane and all. And proxy is the one which will establish the communication between the nodes. It's a network establishment. So I've said in a very high level previously, but if you're going jumping into it, this is what is the control plane components. Now, let's go and talk about the next one. So they were trying to talk, give the definitions and all that. This is where I want you to invest your time to. I was just giving a heads up ఇస్తున్నాను. But I want you to really go and read it. See, QAPI server exposes the Kubernetes API to enable requests to the cluster from inside and outside of the cluster. So what it is trying to say, it is the one which is exposing the API, Kubernetes API, so that any other wants to interact in, so whatever it wants to interact with inside and outside, it's going to happen from the Kubernetes API server at CD. It's a key value store that maintains the state of the Kubernetes cluster and the configuration. Both are different state of the cluster and configuration of the cluster. Scheduler, the one which is taking decisions about whatever to create pods within the assigned node, selecting a node, and then to run on whatever it is. Control manager, there are multiple controller managers. We talk about it, but all things are there. There is node controller, job controller. Okay, there are a lot many controllers. Then you can there may be high just a high level, but you will see definitely see a lot many controllers which will be there. Group controller manager, and then you have cloud controller manager. So as this is coming because they are PaaS offering. What is platform as a service? So they're providing this container as a service solution, AKS, to us, and that's where then another cloud controller manager, which will end of the day interact with the our controller manager only, the cluster cloud controller manager only to do anything like inside the Kubernetes. And then you have node. So that's very high level, but there are still more components involved and all that. Kubelet that maintains that ensures that the containers are up and running and communication. Everything happens to the kubelet. Kube proxy is the one which is the network proxy that maintains the network rules on the nodes. Uh, and container runtime, which will help in terms of creating containers and all that. So this is more in depth about they spoke about a client Kubernetes cluster point of view. Now on a worker node point of view, what is happening? It's an end of the day Azure virtual machine. That's what they're trying to show. In that there's a kubelet functionality which will help in terms of managing the entire configuration of that particular worker machine, where it responsible for running containers and communicating with the control plane and everything. Container runtime is the one which will establish creating containers. Proxy is the one which will help in terms of communicating with the other nodes and everything. So there you see there's a virtual network interface NIC is going to get created, and that's going to get linked with this. So every machine will have a NIC, and that is going to interact with the proxy. And your NIC can be connected to Azure Virtual Network, and that's what they're trying to show. So when you are using Kubernetes service to be created, if you remember, there will be you can create an Azure network. And this here, if you see containers, they can interact with Azure disk. They can for storing your data in it, or you can store your into Azure files in your storage account. All these things is what you are seeing. So that spoke about what is the virtual machine size and all that, OS disk, resource reservations, all these things they were trying to talk. Now, when let's get into the next set of concepts which are there. Pods, node pools. Pods. What is a pod? So this terminology belongs to Kubernetes, pods and all that. You will usually refer in Docker, you will not see the word called pods generally used as containers, but pod in Kubernetes, it's a group of containers. And why will you actually, so group of containers is just the word? No. So when we want to run a workload, we have a definition of how you have to group your containers and all that. So sometimes in your application, when you're designing, all this will be set up from the from where? From the configuration, config YAML, which we try to deploy an application in the second session or third session. We try to deploy an application. So that's where we were trying to talk about how, there you can mention how the prods have to be created and in each which pod what after group of containers will be there. So they share the same network, storage resources. That's the whole concept here. Why do you wanted to group in such way? Now you wanted your set of applications that is nothing but the containers which are running in those applications. We wanted to them to be in part of same network and having the same storage devices and all that. So you'll not try to create multiple Azure files, right? You may create only one file share and you wanted that to be containers whichever are being created in those cluster in different nodes. They have to have access to those file share, whatever it is. Then you would definitely term it as pod and you will say that they have access, so and so. It's much more easier, right? So understand, you have to try understanding those in this way, and that's when it will be much easier for you to remember what is a group of containers that will share same network and storage resources. So you research, but most importantly, prepare on these pointers point of view for your interview in that way so that you can talk about it. Now, node pools. What is node pools? This machine is a node, but as I said, when you're creating a cluster, it's going to create VMSs, virtual machine scale sets. So they are in agent pools or node pools, whatever it is, a set of VMs which you'll group and create, scale, whatever it is, managing the nodes. Node resource group that will be created when you're creating the cluster. So there will be a separate part for it. I can show you all these things here. So you see, managing the entire node pools and all that, we can actually talk it from there, talking about it. And when you're creating, you're going to create the infrastructure resource group and all that. So they were also talking about it, or road resource group and all namespaces. This is something very important. What is a namespace? Why are we choosing Kubernetes? What is a container in general? Why it is secured, or it is lightweight, or it's easy, and all that? It is creating an isolated environment. Previously, how did this Kubernetes has emerged? First, what happened? We used to create servers, if you remember. We are creating in servers is what the applications used to run. Means there is a machine, and inside that you will run install the application and all that. Now from there, the next level is virtualization. Within one machine, you are creating like VMware, or there are like where you can create multiple virtual machines, and inside these virtual machines where you wish to run the applications. And from there, the migration shifted to the containers, where within a machine, you will create containers, and the containers are so lightweight because at the end of the day, here, if you see, they are still OS. That means they're going to consume huge amount of resources. Here, not really. You are going to create a container which will be limiting and which will be sufficient for running the workload. That's it. Nothing more than that. If you wanted to do something more than that, you have to build another new image out of it and ensure that the image can be turning up into container as a runtime instance to run things. Now, namespaces, we said grouping of all one or more containers into pods is what we have mentioned. What is namespace? It's a logically grouping uh, the uh, the pods, deployments, everything. So that's where they're trying to say Kubernetes resources such as pods, deployments are logically grouped into namespaces, and that will create a different isolation within the cluster. Within the AKS cluster, we are actually defining a namespace, and we are going to create pods in it. Now, when in the third session you would have observed, I try to deploy an application inside to run the application inside the cluster. I haven't defined anything on a namespace point of view, what it is. So when you don't give a namespace, don't give a proper namespace and all that, whatever pods you're not proper namespace, name to a namespace is not a question. When you don't have a namespace, assigned when you're creating your pods and all that, it is going to use the default namespace, which is what you're trying to. Default namespace allows you to start using cluster resources without creating a new namespace. I didn't create a new namespace, so I'm using the same. These are all existing ones, namespaces, which are there in the cluster. You want, you can use it. We will create our own private name, our own naming convention that is necessary for the application to run. But this is what it is. There are different namespaces. One of the one main thing is default. So if you don't give a namespace, where does the pods will get created? It will get created in the default namespace of the and where what namespace, as I said, it is creating an isolation within the cluster. So the containers, pods, everything which are there in this container will not can't be interacting with the namespace which are there in this. If they want to interact, there is a way. You have to use FQDN, fully qualified domain name and all that which we refer. We will try to address that later on. But this is creating an isolation between different containers running. So when I create a pod and all that, I would definitely say in which namespace I want it. If I'm not mentioning, it's going to go in default. That spoke about different namespaces. Good to have an understanding about what different namespaces are there, but okay. They try to talk about it. Engineering kube system namespaces, kube DNS, kube proxy, kube dashboard. That's used for admin users and engineering users. They have created the namespace and engineering namespace, and they try to run a block service, which is end of the day having pods, which will applications and all that. Now cluster modes. So I would definitely go. We always prefer standard modes. So this is still in preview. I haven't seen much on the automatic point of view, but it is maybe we have to understand more on the automatic, but still in preview, so not much will be expected from it. Nothing also to be remembered more on this. This doesn't suffice cluster configurations or features and all that. I would recommend you to understand what is the importance of availability zones in terms of the machine is in a zone, missions are created on the zone point of view and all that. And the importance will be given how are you upgrading your Kubernetes cluster versions. So there will be, you need to patch your Kubernetes cluster. So you will be like from 1.317, you would be going to 1.3 to 1.1. Okay. Then how would you update your enable with patch, enabled with patch or what is it? You will not enable it and all that. Okay. And the next one, authentication. So here, these concepts you may have to, I will say among the ones which I've seen, which I'll definitely feel, which you have to know is identity. Yeah, I'm able to go between this and remember where you will find identity and all that. I would recommend you to do your due diligence in reading the documentation, understanding where you can find the concepts and where, and get a hang of the concepts which are involved. Now, if I go into the identity IDAM part of the AKS cluster. You understand this. Local accounts with Kubernetes are back. Microsoft Entra ID with Kubernetes are back. Microsoft Entra authentication with Azure are back. So there are three RBACs. One with local accounts with Kubernetes RBAC, one with Entra accounts with Entra authentication with Kubernetes RBAC. The other one is Azure RBAC, general Azure RBAC with Entra ID authentication. They themselves explain what are those, but we'll try to let's deep dive from the access identity management. Now, generally, I've seen more on the Azure Kubernetes RBAC, Microsoft Authentic ID authentication with the Kubernetes RBAC. Now you can create role, what type of permissions should be needed to users or group of users uh, to access the workloads that are running in the cluster. You can scope permission to a single namespace or an entire cluster of it. Now you see what is the importance of a namespace. Creating an isolation will help in terms of managing the access also. You can create roles, you can assign roles to users or groups to a specific namespace. And that will not be defined, the same access level may not be defined to some other namespace, which is running logically inside a AKS cluster. I hope this is clear. So RBAC is what is it? So RBAC here is more about creating the roles, using the roles to manage the cluster and get the whatever it is and application which is running inside the cluster. So you can define permissions. How can you define permissions? So they will be mentioning more on what how you can manage the permissions, everything, and roles and cluster roles. If you are creating roles specific to a namespace, you see, granting permissions to respected to a namespace, then they are called roles. If you are wanted to create a role which will can give access or permissions to the entire cluster, we refer them as cluster roles. That is the difference. Role bindings, it's called role assignment in generally Kubernetes language. We are referring them as role bindings. You are assigning such so and so role cluster point of view, then we call it as cluster role binding on a cluster point of view. If you're assigning to a specific namespace, the role assignments and everything, then we call it as role bindings. And here they were trying to talk about what is Kubernetes RPAC. This is designed to work on Kubernetes resources within your AKS cluster. And Azure RBAC is designed to work on resources within your Azure subscription. So if you wanted to have more access, ensure that you're controlling more access on it from a user, from an application point of view on any users or groups and all that. That's when you will try to manage things from a Kubernetes RBAC. If you are focused more on ensuring the access to cluster will be given from who will can able to do run kubectl, till what level of information they can access and all that, they will emphasize more on the Azure RBAC, which is recommended. There is nothing as such so recommended at this stage. We are saying that enable enter authentication in whatever is the case is the question. Now, how does the authentication happens? They were trying to talk here. API requests will be first sending authenticated from the Azure Active Directory point of view. The next term comes authorization. What is the difference between authentication and authorization? Are you the right party or not? Is the authentication. Now, even if you're right party, till what level you can go and access things is authorization. Okay. So once your authentication is complete, the next authorization will be defined from Kubernetes RBAC or Azure RBAC. And once your or whatever right thing you have, based on that, you can retrieve the data or on SD cluster accordingly. So built-in roles which are there in Azure RBAC, we're trying to talk about it. So if you see here how the authentication, the engineering user is the first one who came in. The authentication prompt on first kubectl session. So you will try to have kubectl details, and then you will run the kubectl command. How in generally you are trying to retrieve token and communicate and all that. So all these discussions are happening, but you remember the one command. Yes, there are a lot of commands which will be coming. So they'll ask you one simple question: how can I get the credentials of the Kubernetes cluster? If you remember, it is AZ hyphen space AKS space get hyphen credentials, right? So let's see if at all they have anything on AZ AKS get credentials to obtain Kubectl configuration. On the Kubernetes context, you are using AZ space AKS space get hyphen credentials. Now, if you want to run this, first things which you need to should ensure is you are signed in into the authenticated properly on Active Directory or Enter ID, which we are right now terming it as. So unless then the cluster details won't be there. Unless you have the cluster details, kubectl command won't be running. Well, it means it doesn't know which cluster you wanted to communicate with. So all this is very important. So till here, I try to explain you. You can get to know further meaning about it and all that later on. The next concepts which you have to learn is networking. The networking policies which are there that will help. Network policy is the one which will help you to define rules. Okay, the ingress and egress traffic between the pods. So within the cluster, you can define your rules based on this one. At this, when you are trying to create, we were actually using none. But remember this. And you remember that there is kube proxy. And when you're trying to communicate, you are using network configuration Azure CNI overlay. Okay, where you can use your own virtual network. You can create your virtual network and ensure you are running it, or it will create it for you. DNS name prefix for the cluster and all that. We'll get to it. So I want to go for networking. First, let's understand networking concepts which are there. So ingress controller is something which you will keep hearing a lot, and also load balancers you will hear a lot. And in AKS cluster point of view, network policies is also something which you will hear. Yeah. Then we have, so I've started this session low, this is not sufficient to just cover networking concepts. What I'm thinking is I will talk few more concepts which will be there, which you have to know and you can revise or try to read those concepts and come back to the next session so that you will be, when I talk about it, you will have a better understanding on those items is what I'm trying to say. So ingress control is what is important. Load balancer, which we call it as we try to create a service in Kubernetes cluster for the load balancer to be there. And when load balancer is gets created when automatically with your machine itself, and when you're creating a cluster and all that. And network policies, I've already showed you the Calico and all that, where we set up things to which will can manage this traffic within the cluster. And similarly, the other concepts which you have to revise, understand or look at are storage. How do you link your containers uh, with the uh, files or disks? There is also container storage, your container storage also, which will be there. Sure why they are not mentioned this, but there is this container files and all that. And What else? So you need to know, we will see certain scenarios where I'm trying to connect a storage account, connect a files, which generally when because in those scenarios is what I want you to understand. How are we linking a disk and how are we linking uh, the files which are considered as a persistent volumes, which will help in storing the data. And see, end of the day, I'll show that example through the this one. It's a config YAML itself when you're trying to deal and all that. Now, the other concepts which you need to be aware is scaling. All these concepts will be coming down here. Storage concepts will not be coming down more on this. But if you talk about scaling and all that, yeah, the scale. There, you can scale in terms of nodes and terms of pods. So you have pod autoscaler and you have cluster autoscaler and all that. Now, cluster autoscaler is more on the front of virtual VMSS, and pod autoscaler is something which you can set up in the config YAML itself. And that's where they're trying to talk about how do you set up and all that. The next ones which you see is node health. How do you check your node health? How do you check your container health? And how do you check in terms of your cluster entirely in a holistic in a cluster point of view and all? We'll be seeing those. So that will cover most of the majority of the configuration. So we are talking about node pool configurations or nodes configurations and all that. Then networking concepts which will be there, and then the integration. Okay, this is something. So when we're trying to talk about security, if you try to talk about security concepts, they will be trying to talk about how do you do a registry, that is a container registry security, cluster security, node security, that is your machines. How do you set up your authentication? How do you store your data? So as I mentioned, when you're trying to configure, we're trying to most of the configurations will end up touching this part of how are we securing our cluster and all that. Okay, and so this is Istio service mesh. I would definitely say you should carry some understanding, but I would say this is a bit advanced concept. Uh, and Azure policy is more on the management part of it. If you want to apply some specific conditions that your cluster should be in so and so way and all that, you can manage that through policy. And within inside the cluster, how your pods, containers, everything should be running and all that, also you can manage it. But if you wanted that to happen, then you have to use Azure policy to be enabled. So that within your cluster, how people, users, are being given access to your clusters through the uh, authentication and authorization, but you may not have control or you may not be able to, even you educated them, you wanted to govern your cluster and all that. That is when this Azure policies will help you there. Now, as I said, monitoring point of view, how do you want to monitor the track the health of the containers or the entire cluster point of view? So there are different extensions which are in place right now. Prometheus is there, Grafana is there, and container insights are there. Or every organization will end up using not all three of it based on their way of monitoring and all that. Most of them, 90% would definitely rely on, 95% will definitely rely on container insights, which is something Azure is providing, which will help in terms of monitoring in a container specific point of view. Prometheus is also the most preferred tools in terms of monitoring the entire the application cluster level point of view. Grafana will help in terms of more on writing queries and build your custom data whichever you wanted and all that. So good to know all these things. Security is where the other ones which we'll be talking, but as we keep going on, it will be more. So in storage also, some things which I feel something is important is sensitive data. Are they talking about anything on sensitive data? Sensitive. So how will you, the way we store sensitive data is the way it is collected and all that, it also differs. The way it will change a lot. So you'll end up integrating with Key Vault as well. Like you'll end up integrating your Key Vault to retrieve your secrets from the Key Vault and access so and so things in your cluster. So there are many things which are going to happen. So this marks to majority of the concepts in AKS point of view. I will definitely talk if on Azure networking service, networking concepts a bit more. And then I think we were able to cover most of the configurations and features of the AKS right now prime for the initial level. We'll try to touch POC. I wanted to more interested to touch from POC standpoint all those and explain because we can speak anywhere or you can go and read anything and all that. But I'll try to find a POC which will help me in terms of covering majority of the concepts. And slowly, different POCs have to ensure to achieve that or talk about those features. But I'll do that in the next upcoming full sessions. Thank you.